Throughout the section 3.2 homework, you want to be sure and pay careful attention to the blue writing next to the answer box, because many times they are particular about how you do your rounding off. So for problem number 1, we're using the continuous compound interest formula. The formula is on the formula sheet, which is in the Moodle page, and it's also on my lesson videos. So for continuous compound interest, we use the formula PE to the RT. The E is the natural number, 2.72 approximately, but we will use the E key on our calculator. So substituting the values, we have 8,000 E to 0.0399, and T is 9. On my TI calculator, here's the 8,000. The E key is here, which we access by using the second and the LN. Now you can use a time sign between the two numbers, or you can type it exactly like we wrote it. Now to 2 decimal places. So to 2 decimal places, that would be here. Since the number after that is a 9, we'll make that a 2 and drop everything after it. In problem number 2, we are again using the continuous compound interest formula. This time we'll be using the value for A and solving for the P. Now I want to show you about using your calculator for this. You can do the calculation beside the P and get the number. Then we will be dividing both sides by that number, whatever we get. So our answer is going to come out 6,400 divided by that number. Now to do this properly, you do not want to round off. So when I take my calculator and do the E to the 0.0748 times 11, I get this big long number. You do not round that. If you round that, you will miss the problem. We need to divide 6,400 by that number. On my calculator, I type 6,400 divided by. Now, to get that number, I use the button at the bottom that says A and S. Second, and then the negative key. Now the answer needs to be rounded to 2 decimal places, so that would be 2810.88. So in this problem, we're trying to find the value of T in the continuous compound interest formula. Here's my formula. A is 74,000. P is 57,129. R is 0.069. And then T just stays a T. So here's what we do manually to solve that. We need to begin by dividing both sides by the 57,129. And as I pointed out before, rounding off at this point will give you an incorrect answer. Now we're going to take that number and store that on your calculator. There's a button over here on the lower left that says STO with an arrow beside it. If I push that button, I can then identify this number by one of the letters. I'm going to use the letter K. It's just a habit. You can use whatever letter you want. So I'm going to say alpha and K. So that number is stored in my calculator as the letter K. I'm going to write that over here. So what I just did, that calculation, 74,000 divided by 57,129 is K now, and we don't have a number beside the E. So now we convert this to LOGs. The three steps. Number one, the base is E. Number two, the logarithm is the exponent. And then the other number is the K. If you don't understand what I just did, please watch the lesson videos. To finish it out, we need to divide both sides by 0.069 to get the t by itself. So on my calculator, I'm going to do the log base E of the K that I just stored. Log base E is the ln. So I'm going to do the ln of the number I stored, which is K, and I'm going to divide that by the 0.069. Now notice in their blue writing they say do not round until the final answer. So if you aren't doing like what I just showed, please have some way of doing it so that you don't round until the final answer. So we need to round that answer to 2 decimal places. So we'll again be using the continuous compound interest formula. And in the compound interest formula, the continuous compound interest formula, the time is always in years. So we need this 60 months to be years. Now 60 divided by 12 comes out to be 5 years. So when we substitute 21,396 for A, 13,400 for P, we need to use the 5 for the T, not the 60. Now the process is very similar to the one we just did, so I'll go through it kind of quickly. We divide by the 13,400 to get rid of that. We'll type this into our calculator, store it for K, and do our conversion. LOG, base E, logarithm is exponent, and then the other number. So R then would be the ln of K divided by 5. So here's what it will look like on our calculator. Now I'm pretty sure that when they say round to 3 decimal places, they mean round the answer box. Now the number that we get on our calculator is a decimal number. When we move the decimal between the 9 and the 3, that gives us our percent number. And that's what we want to round to 3 decimal places. So looking at this 8, since the number after it is bigger than 5, we want to round that up to a 9. So 9.359 would be our answer. The compound interest formula looks like this. And in the first one, we want to do compounded annually. So we're going to take 800, 1 plus 0.09. So now we'll type that into our calculator. Now to make it shorter, I don't need to type the 0.09 divided by 1. I can just type 0.09 because I know that's what it's going to be. Use the exponent key to get the 6th power. And then round to the nearest cent, which means 2 places past the decimal. 1341.68. We need to find the interest. The interest will be the difference in how much we end up with and how much we started with. So it's 1341.68 minus 800, or 541.68. Now we want to do the same amount, same length of time, but compounded quarterly. So our formula will look like this. We've got A equals P. I'll go ahead and fill that in. That's 800. 1 plus R 0.09 divided by M. For quarterly, M would be a 4. And that would be for 6 years quarterly. Here's my calculator. And as you can see, I'm typing exactly what I have written. And to the nearest cent, that would be 1364.61. And the interest would, of course, be the difference in that number and the 800. Before we go on, I'll just point out that the interest is greater if it's compounded quarterly than if it's compounded annually. The question may arise in the future. So finally, we want to do the same calculation, but compounded monthly. So our formula for compound interest, with the values substituted in, here's the 9%, monthly would be a 12, and here's the 6 years monthly. As you can see, I entered it exactly like I have it written over on the left. To 2 decimal places, that would be 1370 and 4 cents. And as before, the interest is the difference in that number and what we started with. So again, we just take that number and subtract 800. On number 6, we are back to the continuous compound interest formula. So in the continuous compound interest formula, we need to substitute these values. So we've got A equals the 2,000 that's invested is the P. 4% would be the R, 0.04, and the T would be the 3 years. So on my calculator, I would do the 2,000 second ln gives me E, and 0.04 times 3. As I mentioned earlier, you can also put parentheses on those numbers, just like it is there. To the nearest cent, that would be 22.54.99. So on number 7, we're using the compound interest formula, and we're trying to find the amount in the beginning that will give us 9,000 in the future, meaning in 5 years. So we're going to use the 9,000 in place of the A in the compound interest formula. Similar to what we did earlier, we will do the calculation next to the P on our calculator, and then we will divide the 9,000 by that. So here's my calculator. Here is the 1 plus 0.05 divided by 2. And by the way, the 2 comes from the semi-annually, raised to the 5 times 2. So this number is the calculation next to the P. And we need to divide 9,000 by that. 9,000 divided by second ANS. To the nearest cent, that would be 7,030 and 79 cents. The rest of it is asking how much should you deposit now to have that amount in 10 years. So we're going to do the same calculation but change the 5 to a 10. On my calculator, I can use the arrow key to scroll up until the 1 plus 0.05 divided by 2 raised to the 5 times 2 is highlighted. I can press enter and it will copy that down at the bottom. I can then change the 5 into a 10. So same calculation, but with the 5 changed to a 10. And as before, I want to divide the 9,000 by that number. And round to 2 decimal places. Number 8, we are again using the continuous compound interest formula. Our interest rate is 5.8 or 0.058, and we need to know the amount now, which means we're looking for P. To have 8,000, which is A, in 9 years, which would be the T. So in the continuous compound interest formula, we will have 8,000 PE to the 0.058 times 9. And we've done this numerous times already. We'll do this calculation on our calculator, and then we'll divide 8,000 by that number. Rounded to 2 decimal places, that would be 47, 46, 66. There is a formula for annual percentage yield, APY, also known as effective rate, on your formula sheet. It's also in the lesson video. Effective rate. I may also have the APY, I'm not sure. However, the formula goes like this. We use a 1 in place of the P, and we do the same calculation here as before, and we use a 1 in place of the T, and subtract off the 1. So $1 for 1 year, and that gives us our annual percentage yield. However, that formula is on the formula sheet. For 4.33 compounded monthly, we would have the 1 plus 0.0433, 4.33%, divided by 12, with an exponent of 1 times 12, and minus the 1. Now notice in the answer box they already have the percent sign, so we got to convert this to a percent. That would be move the decimal 2 places to the right, and we also have to round to 3 decimal places. So that would be 4.417. For the second part, we do the same calculation. So I'm going to take out my calculator. When I cursor up and press enter, I can now do some modifying. For example, this one says 4.34%, so I'm going to need that second 3 to be a 4, and it's compounded quarterly, so I'm going to need to change the 12 into a 4. Now I can type the 4 and it'll replace the 1, and I hit the DEL key to get rid of the 2. Same thing up in the exponent. Type the 4 in place of the 1, DEL to get rid of the 2, and there's my calculation. Now if you didn't follow that, you could type the entire calculation again, and rounding to 3 decimal places, 4.411%. Notice in number 10 that we are looking for the time in the standard compound interest formula. So here is our compound interest formula. And we're looking for the T. So we start off with P is 5,000. A is 15,000. R is 0.06. And M is 12. So we're trying to solve for the T. We'll begin by dividing both sides by 5,000. Now this time the division on the left comes out nice and even. 15,000 divided by 5,000 is a 3. I did show you in one of the other problems how to store a number if it is not a nice even number. So at this point we are ready to convert to logarithms. And I'll just point out that in the expression that we have here, we have these three quantities. Again, you could try 1 plus 0.06 divided by 12. If that were nice and even, you could be typing that number. If it is not, make sure you do not type that number. So these are the three quantities. This is the base, and the exponent, and the other number. You know what that means if you watched the lesson video. So we convert to logarithms. The base is the 1 plus 0.06 over 12. Logarithm is exponent. The other number is the 3. Now, we need to do this calculation on our TI calculator. So I'm going to take out my TI calculator. I'm going to use the math key, scroll down to where log base is. That's the A choice. And fill it in. As you see, what I have written over on the left, the bottom is 1 plus 0.06 divided by 12. I have not rounded anything off. And the other number is a 3. So that number comes out to be 220, etc. And again, we don't want to round that off. What we do need to do is divide both sides by 12 to find the value of t. So on our calculator, we will just say divided by 12. Now, let's write this down and then have a look at the instructions. In the instructions, you notice they say round to the nearest tenth of a year. Now that's one place past the decimal. So in our answer, we need to round here where the 3 is. Since the number after it is 5 or larger, we will make that a 4.